Bismillahirrahmanirrahim. Assalamu alaikum, my dear students. Okay, that day with Anik, when we had the last class, we had discussed linear search. Since there were less strength in the class, so we made a video while teaching this to Anik, who was the only student present at that time. And also, I promised that I'm going to share a video for this bubble sort. So those of you who have missed the class, they can just learn it through this video, and they can do well in the upcoming exam, obviously because the topic is included with bubble sort. Now you see this snapshot is taken from your screen, from your book. I'm going to make some changes into this, so I'm just going to switch the screen. The changes what I'm going to do is like this. I'll explain this before I would need to explain a couple of things before we actually get into this one. So it's a minor difference between this and this. As you can see, I have not taken temperatures, instead I have taken numbers. Again, I've also skipped first from here. I've only used last, this identifier last, because we don't need this one. In some cases we would need this, but in our case, in current case, we are not needing it. And then swap was written here, value was false was assigned, so obviously this is a boolean variable, and in mine, in the change addition, I've put swap over here before repeat loop it would actually even start. So I hope you can hear me well. What happens is, bubble sort, as the name implies, in our fizzy drinks, in a glass of fizzy drink, what we see is bubbles are created at the base of the glass of the container, and then they goes up, and then they expand, they grow bigger while they go upside, and when they come at the top they just blow away, getting higher or bigger. So the same way, if you would have these numbers, let's say, just taking these numbers, let's say 7 here, 2, 5, 9 and 1. Okay, obviously this list is not sorted, and using this bubble sort we are going to use two loops. The outside loop is going to give us the outside loop is going to give us the starting and ending range of the first pass. By pass, what I would mean is we are going to do swaps and comparisons and swaps, I'm sorry, comparisons of first and the second number, or the first number and the number comes after this, and the current number and the number comes after this, and the number and the number comes after this. So at a time we are doing comparison between two adjacent numbers, the values. If this one, these passes are going to go through until we reach the last element that was given by the outer loop, and these passes and comparisons are going to be repeated by the inner loop. So these loops would be called nested loops. Okay, not necessarily they would be of same type. Let's say if you're using a for loop outside, you may or may not be using the for loop inside, or you're using an until loop outside and you may or may not be using an until loop inside. So depending upon that scenario, in repeat loop is used when we do have a condition to break a loop or to meet, and the for loop is a counter loop, is not a condition loop. So we'll see what loops we are going to use. So now inner loop is going to do the comparisons. Let's say 7 and 2 will be compared through some mechanism, will be given a starting value, and then obviously an array is going to be used, and we're going to say, let's say this list is called num. So obviously num1, which is index 1, plus 1 will be index 2. Num1, if that one is this number 7, which is num of 1, is less than the number that is coming after this, which will be num of 1 plus 1, or num index plus 1, whatever the index is. So if these two, if the lesser number is on the left hand side, then they are going to be swapped. Now then we are going to check if in our case obviously this number is going to be swapped, and this one would become like this 2 7, and and then this obviously 7 comes here, 7 and 5 are going to be checked. In our case 7 is still the largest number, which is on the left hand side, should not be on the left hand side, should go on the right hand side, which is the value after this. So there will be another swap like this. 5 won't come here, or you can just do it like this. 7 comes here, then 5, 9 and 1 remains the same after the first uh, pass or first iteration of the inner loop, or first iteration of the first pass. Now at the second iteration of the first pass, these two would be compared. Obviously 7 is at the wrong position, so 5 would come here, 2 remains here, 7 would come here, and the rest remains same. Now in the next time 7 and 9 are going to be compared, so they are at the correct positions. 7 is on the left hand side, the bigger number 9 is on the right hand side, so no swap would be done, only the comparison. 7 9 1, and now this will be compared. Ultimately 9 obviously at the wrong position, it should go at the right hand side, so after the first pass, the fourth or fifth iteration of the first pass, this will be the face of picture of the array or the list. Sorry, not 9, it's 1 and then 9. Now you might notice that after the first pass of the outer loop and all the iterations of the inner loop, we have the biggest number of the whole list on the right hand side. See, but still not necessarily the list is still not sorted, whole list is not sorted, it's just one number has got the correct position, has gone to the right hand side, or the most most high position. The highest number is the most high position, which is 9. Okay, now these the outer loop is going to do the second pass, and obviously when 1 out of 5 numbers of the list, or 5 values of the list, one number is sorted, we do not need to include this one in our next comparison or next process. So the outer loop is going to do -1, okay, in the last element or in the boundary or the limit of the list, and going to give control to the inner loop so it can do comparisons and swaps. So next time obviously excluding 9, if I could remove this, just for your understanding, if I could remove or undo all this, I would drop this position and would only do comparisons of these 4 numbers, okay, which is this picture. And you might have understood this, that the 7 after the second pass and the second pass and all the iterations of the second pass has been done. 7, which is the most largest number, would come here, and rest of the numbers would do like this, something like this. Okay, now how are we going to do the swaps? Moving on, now let's say you have number 1 value assigned is 5, number 2 value assigned is 10. How to swap these values? That is, transfer value of number 1 into number 2 and number 2 into number 1. Let's say you have these two boxes, num1 and num2. You have 5 value here and 10 value here. You want to swap this like this. So obviously if you're going to put or copy 5 here directly, it is going to replace 10, and you would not have 10 any longer. In both of the sides you would have 5, a copy of 5, either of these numbers. So how do we do this? In order to do this, there is a simple process. Hope you guys are already familiar or aware, but let me just help you with this. So what we'll do is, we'll just take a temporary number, let's say temp, and we are going to assign num1's value into temp. So we would have copy, let's say number 5 in number num1, and another number 5 in temporary, which is the copy of this. Now we do have uh, let's say num2 num1 is free, so we're going to use num1 to copy value of num2 into it. Now we would have 5 stored in temporary number and 10, which is the value of number 2, stored in number 1. Now we have 10 in both of these numbers, copy of 10 into num1 and 10 another value in num2. Now we are going to do num2 and going to assign whatever the value was in temp, which was 5. So ultimately at the end we would have 5 transferred into number 2 and 10 transferred into number 1 by using a third variable called temp. So that's all. We do have another concept. I had written down this, but it's going to make it more complicated. You can just take a look for this Boolean variable down, how it's initialized false, and it would only have another value. Boolean value would only have two values, false or true, 0 or 1. So in our Sudoku algorithms, we only have false and true. Now, if it meets certain condition, we can assign this another value true, which is the other value or inverse value of whatever was assigned before. So now in order to break the loop or use it as a condition in the repeat until, we can say until not down. Not is a Boolean operator. So just like and or, if you put not and variable down, down means whatever the value was assigned before false. If obviously by doing not down we are getting true, so until it's true, not down means until it's true, this repetition is going to be is going to be carried out. Now the moment it becomes true, this would repeat until loop is going to be broken up, and the statements after this are going to be executed. So same thing, going back, this is our this is our bubble sort algorithm. We are initializing a last variable 10. In your case it might be given already. After the declarations have been done, you might have been given a list of let's say array of size, let's say 1 to 10. So obviously last number or last index is 10. And same way I've just explained to you, swap is going to be initialized true. I'll let you know why we're using swap, this variable. Why is it necessary? Or it might be a question in the papers. Why we're using a swap loop? I mean a swap variable. What issue would occur if you're not using this variable and you're not using it here and not checking it here? Because we already have a condition last is equal to 1. When last becomes 1, after doing all these -1 -1 -1, obviously there will be a point when it last variable will be 1, then we can break the loop, because the whole list has been scanned or compared and swapped. Okay, so they may ask why swap has been used. So after we are done with this, after I go let you through the whole pseudocode, dry run this, then you should have an answer why we're using the swap, and also why we're using a repeat loop as an outside loop, why not a for loop. Then we already know how many times the swap or the comparisons is going to be done, because we already have a list of known starting and ending. Okay, so they might ask a question, and after I'm done with this, then you should also be able to understand and know why we're using a repeat loop at this outside as an outside loop. Okay, now outside loop, just say repeat. Fine, we are going to repeat all these steps that are falling under this before until. So all these are going to be repeated because of this repeat outside loop. So what is going to be repeated? Let's say there is another loop inside that says for index another variable that will be declined outside somewhere. Just to save time, we are not doing it in A levels. And now assigned a value 1, or you can say just like here, they have already assigned a value first and starting from first to last, but I'm just going to, because I know the first number is 1, so I'm going to start from 1 to last. Why last? Because I would be needing this somewhere here to decrement or increment this number, and make some checks because of this last. So I cannot just assign 10 or something. So last minus 1. Okay. uh, why last minus 1? Because if we have a list of 10 numbers, these swaps and comparisons will be one less number times than the whole bound or the whole size. See, when I'd explain this to you, so 1 swap and comparison, 2 swap and comparison and swap, 3 comparison and swap, and 4, not the fifth one. After the fourth swap and comparison, the list would be in a position that the highest number would go at the last. So for a list of 5 numbers, the swaps and comparisons would be 4, one less number times. So this is why we're using last minus 1. Now if number of index currently is 1, by that I would mean at this position, at the first position. Now if that number is greater than the number comes after this, if this number 7 is greater than the number comes after this, which we obtain by doing index plus 1. Okay, so if this is the case, then what happens? Then we are going to do this swap. These 3 steps are the same, just like the one I've shown you here. See these things. It's just we had numbers here, and over there we have index of array. Okay, so these 3 steps are the same as I've explained already. You're using temp number to put one number into it, and you're using that number to get the other ones copied into it, and you using the other number and copying the value of temp into it. So this is how you're swapping first and second position values. Now we are doing swap is equal to not false. Sorry, there is a mistake. We are doing this as false initially, and we are doing it true here. Okay, so if swap has been done, which means something has been done, so we are doing swap is equal to true. I'll let you know why we're using this one. Swap was initialized here and was used changed value here, assigned another value here, and was used here as well. Why? I'll let you know after this. Now if this was the case, obviously this whole thing has been done. We do end if, and then next is the ending statement or for the inside loop for. So this is called indentations, how you putting these values that are following. So this is called indentation. This is very important to understand. If I would write all these statements in the same line starting from the same first position, then you might be having hard time to understand what is happening. So this is called indentation. So and if is falling just below if, and next is falling just below for. So this is the end of for loop, or this is the next iteration or repeat of for loop. So it's going to be checked again, and this process is going to be repeated unless the whole list is scanned, swap, compared and swap. Now then the outer loop, this statement comes directly under the outer loop. So it would say last is equal to last minus 1 should be decremented 1. Why? Because after the inner loop has run once, all the iterations of the inner loop has been done, the highest number would have gone at the last position, so we don't need the last one now. So we can do minus 1. This is why. Now it will do minus 1, and the inner loop is going to go last minus 1. If the numbers are 4 now, the swaps and comparisons will be 3. So this is why another minus 1. This minus 1 would mean that you should drop the last number because we are not using this before going into the inner loop once again. Now inner loop is going to do the comparisons from 1 to last minus 1. Whatever the last value was, which was 4, is going to do swaps and comparisons one more less number times. So there will be 3 swaps and comparisons. Now the whole thing will be done. Outer loop would when all these passes iterations will be done, the outer loop would check until not swap. I'm skipping this for now. Let's say last is equal to 1. Fine, this one is fine. because when we're doing last minus 1, there will be a point when last would be equal to 1. So this is where the outer loop should also break. Okay, should also stop repeating. Now there will be a case when the list has, or this was already in sorted form, was already in sorted form. Let's say one number 1 was here, 2 was here, 5 was here, 7 was here, and 9 was here. If the list was already in sorted form, before we would actually apply this whole algorithm. Now in that case, obviously, when not even a single swap is done after the inside loop has completed its iterations, swap would remain false. Now if swap would remain false or not swap means until not swap means the whatever the value was assigned, if it's not become the otherwise, which is the true value, then you should also break. You should not wait for the last variable to go to 1. You can break it over there if even after all the all the iterations of the inside loop has been done and node swap was done. This means the swaps were not needed. It was already sorted. So in that case, you can break it right there and then, which means if this was the case, values were 1, 2, 5, 7, and 9, and after these it has checked all these numbers, and you do not need to repeat the outside loop once again. Okay, you can just break it right there and then. Okay, this is called an efficient algorithm, and programmers would be called an efficient programmer that way. It was not going to be an issue if you would remove this not swap, you would remove this statement from here, you would remove this initialization of swap, you would remove all these three things from here, 3 lines or statements. It was not going to be any issue for you to see, but the computer would have gone, even if the list was already sorted, it has done all these steps and repetitions, which is obviously using more time, spending more time and using your variables and locations, addressing and putting your computer or processor into some processing when even if it was not necessary, even if it was not needed. So this is why it becomes an efficient algorithm. So this is your bubble sort. Hope you understand this. If you would have any questions, you can ask me. You can post in the WhatsApp group, or you can message me directly. And wish you best of luck for your exam. Thank you very much. Allah Hafiz.